Okay, so this is recording. Let's give you a synopsis of what we've done so far, just so you have it. Got two simultaneous equations and two unknowns. We add 3 times the first one to -2 times the second one, choosing these numbers so that one of our variables will add up to 0. So we chose to do X. We could have done Y. Could have multiplied this by 4 and this by 7. But this works. So we get this equation when we add these two. Now we can solve for Y. And then we can substitute that for Y in either equation. So I chose to substitute it here, which gave us this equation, which we can solve for X. Okay. Now, everybody's been assigned numbers A, B, and C. D, E, F, and G are defined as indicated. A plus B. I'm not going to read it too. Can you read it? Everybody see it okay? You can write bigger if you need me to. Okay? So now, this system of equations here the backward apostrophe A stands for the value of that, and so forth. Okay? So what I'd like you to do, just real quickly, is write down your system as it would be, and do a couple of steps of the solution. Okay, so everybody did well with this. Now, if I write this, now these don't stand for numbers. These are just symbols. Okay. And then if you do the symbols, do this with the symbols, we're not going to take time to do that, you would get a general solution to any system that you replace. Okay. We might do that with symbols since we missed Tuesday and we're on a short time today. We're not going to be able to do that today. But just to call it a minute. Unless it's got the backward apostrophe in front of it, it's a symbol, it's not a number. Okay, good. Okay, now. There's a bunch of terminology, and unfortunately, you're going to have to read it. And incidentally, this is something that everybody has encountered in Algebra 1. And then again with 3 equations, 3 unknowns in Algebra 2. If you didn't, then you didn't necessarily have a complete Algebra 1 or Algebra 2 course. Doesn't mean you don't know it. You've been through calculus, so you learned some algebra. But yeah, that's something that really we shouldn't even have to talk about, but we do. So it's something I assume that you can master rather quickly. And there are all kinds of online resources. WebAssign has videos too, so I don't think you'll have any trouble. But make sure you don't. Make sure you know how to do this. If you don't know how to do this, you're dead in the water before you start. And I mean, know how to do this by the time the first assignment is due. Okay? And then forever after, because we use these methods. Okay. Let's just take another equation. 4x minus 6y equals 12. Okay, now we know that this is an equation of a straight line. We can graph this straight line. And let me record this. I am recording, okay. Have I been recording? I don't know. Okay, we got 4x minus 6y equals 12. Okay, we can find the intercepts. You know, the x-intercept of this equation is going to occur when y is 0, and the y-intercept is going to occur when x is 0. So we get 2 points to draw a straight line. Or we can solve for y and put it in slope intercept form. But we're not doing that in this course. Okay. In this course, we parameterize. Now, the fact that this is the equation of a straight line, well, it's an equation of something, okay? Turns out it's an equation of a straight line. Means for any value of y you want to choose, you can find a value of x, right? Or for any value of x, you can find a value of y. Well, you can then say, and if you're taking calculus 2, you're going to get to parameterizing more general things later in the semester. It's kind of one of the late things you do in the second semester. That's very important. And multivariable calculus 3 students had never seen parameterization. It caused them all kinds of trouble. So anyhow, you parameterize this. You let y equal t. Okay. So if you pick a value of t, well, then you've got a value of y, and you can get a value of x. Okay. Well, then x is going to equal what? Well, x is, well, you can solve this for x. So you're going to get a plus 6t over there, then you're going to divide everything by 4, and you're going to get 3 halves t plus. Okay. So you're going to say that y is a free variable. Meaning, I mean, we can choose either variable to be free. We got two variables here. You choose either one, you get a value for the other. We chose y to be the free variable. We y equals t, which is then our parameter. Okay. And we get geometric equations. Y equals t, x equals 3 halves t plus 3. Okay. Now, why would you do this? There are a lot of reasons. And if we have more time, and we've been able to meet Tuesday, I'd be able to talk about them a little more. And I'd like to, but we got to. That's long. That's parametric equations. That means I choose values of t, I get points in the line. I get y and I get x, right? It's going to give me the same line that plugging x's and y's in here. You know, pick a y, find x, pick x, find y, you get a bunch of points. And a line on the line. Okay, so those are your parametric equations. Now, we could end up, or we could have an equation like this. Okay. Now that's in 3 dimensions. That's the equation of a plane in 3 dimensions. Just for a quick reference, we can find the x, y, and z intercepts of that equation and get an idea of where the equation is. And I would choose inconvenient numbers. Let me see here. Okay. Now it's 105, okay? If y and z equals 0, then x is 105 divided by 3, which is 35. So $35, 0, 0, 0, 15, 0, 0, 0, 15 is coming in. Negative 15. We can sketch that fine. Sort of. By just sketching the intercepts. And you know what? Sketch is going to come up better if this is a plus 7 z. We can make this a plus 15. Okay. I think that would be very well. But here's x, here's y, and here's z. So 35 is maybe here. Okay. So that's 35 along the x-axis with y and z both equal to 0, and 21 along the y-axis, and 15 along the z-axis. Now we can kind of see how this plane is oriented. We can draw a triangle here. And we see that this thing kind of slopes back like this, right? You get a good idea what that plane looks like. If we have another plane, of course the plane extends everywhere, but that's just the segment of it around the origin. And from that we can see how it extends. If we have another plane, they're going to be at a different angle. Well, two planes intersect each other along the line. Okay. If I take this board here to describe a plane, and I take my plane cutting sword and come down in a straight line along the plane and cut this thing, I'm going to get a straight line here no matter what angle I cut it at, as long as I'm not swirling around, right? So two planes intersect along a straight line. Unless they're parallel. If they're parallel, they might not intersect at all. And if they do intersect, they intersect everywhere. Okay? If they're parallel and they share one point, then they share all points. That means they just, you know, one line right on top of the other, right through these. Okay. Okay, well. A system of three equations. This system describes three planes. And those planes, none of those planes are parallel to any of the others, the way I've written this. Okay? I have to, you know, cheat a little bit to come up with a third plane that intersects, or that's parallel to one of the first two, or in some sense. Okay. So in general, you expect three equations and three unknowns to describe three planes. Now, two planes intersect along a straight line. Another plane that's not parallel to that straight line is going to intersect that straight line at a point. So you're going to have one solution to the equation corresponding to the point where these three lines intersect. Okay. We can solve this system of equations. I would start by just adding the second and third equations, which would get rid of my z. Okay. Then I'd add 4 times the first equation to 7 times this equation because I want to get rid of these two. They give me a second equation and 2 unknowns. And I could then solve that equation very easily. That system of equations, just by the methods that we used with the original equation. Okay. So I would probably start off with equation 2 plus equation 3. I'm not going to write it out again, it's limited time. And then 4 times equation 1 plus 7 times equation 3. Okay. If I add, well, if I get those 2 equations, I'm going to have 2 equations in X and Y, right? I'm going to have some multiple of X, plus some multiple of Y, plus some number. And here it's going to be some other multiple of X, plus some other multiple of Y, plus some other number, right? I'm just going to use asterisk to indicate those numbers. Then you can easily find those numbers. Well, then this can be solved. You get a value of X and a value of Y. And then you can take the values of X and Y and plug it in the original equation. Okay? Just quick synopsis of what I said, didn't record. 2x plus 7y equals 9, 3x minus 4y equals 2, the equation we started with, can be written like this. Then we can solve for y and use what we call back substitution. We take that and take it off the level. Okay. And that's exactly pretty much what we did. We just write it out this way. For 3 equations, we can get the equation into this form. Where we don't have an X here, we don't have an X or a Y here. This is called an echelon form from the way soldiers used to sometimes line up. Where you just kind of have this diagonal here and nothing below it. Okay. We get this form. If this came from some system of equations, we solve for y and get 5 halves. We plug that into this equation for y. And I think we get x equals -3/4. And then we plug that into this equation. And heaven forbid, let's see. 5 halves of 5 is 0.5 halves minus plus 21/4 times 25, 50, 21, 71/4. That's 192/4. 192 minus whatever I just got there and forgot. It was 46. So that's going to give you like 146 over 48. You understand what I'm doing, right? This back substitution, very convenient. Once you can reduce the system of equations like this, back substitution works. And that's essentially what we're going to do in this course. Okay? Even better, you could reduce the equation to this, and you can easily do that. You can add 1/4 or -1/4 of this equation to this, y goes away, right? We can add -32/12 of this to this, and z goes away. And nothing else gets influenced, right? Okay, then we're gonna have a value for X. Now, of course, that's gonna change numbers over here in this equation, right? But then we can solve this one for X. Okay, we can just divide this one by 2. Whatever you get, you divide it by 2, so you have an X. This is supposed to be a Y. Oh, this is supposed to be a Z. So I screwed this up completely, but you get the idea. Okay. So don't pay any attention to my numbers. Yeah, figure out your own numbers. So again, I can eliminate my Z's here. That should be Z, this should be Y, this should be X. Eliminate my Z's. Then I can divide this equation by 2, whatever comes out when I've eliminated the Z's, and I just get a Y, and I can use that to eliminate this, right? So I can easily, if I've got this form, pretty easy to get this form. Of course, this form is the complete solution, right? Okay. Oh, well, there's more. And what I'm gonna have to do is I'm gonna have to make a video. And you're gonna need to watch it. Because having been able to do only one of the 3 hours of class we have this week, and having a pretty tight schedule, especially since we might miss more snow days. The way I set the schedule up originally, there were 3 assignments 1 week, 2 assignments the next. Okay, well now there are 3 next week and 3 the following. Okay, and we can still compress that, but your life is going to be easier if we don't have to. Okay. The stuff we do here at the beginning is pretty straightforward, but they're important ideas. So you want to watch the video, you want to read the text, you want to work the homework in such a way that you come in. Okay. I should be able to post that video. The system cooperates and lets me in. I just changed my password the other day. It tells me I've only got 1 day left. I've got to change my password if I can't do anything. So a little irritated with the system. Hopefully I'll be able to resolve that tomorrow. But anyhow, you gotta get a video. And I'll post this one. It should be posted later on today. Okay. You have the web assigned.